Under 3.6, we are supposed to understand about inequalities on graphs. And we are on page 49, and we need to understand the bold statement down there. And the first one is talking about you may be asked to interpret physically the solutions to inequalities by considering the graphs or functions that are related to them. And this relationship just simply summarized here. When a certain function of x is within the same set of axes, is below another function of x rather, or rather this graph is above this graph in the same set of axes, is below. I mean, when fx is below gx, then fx is always less than gx. When now fx, the graph of fx is above that of gx, then fx is greater than gx. And this one is just illustrated in the diagram below. If we have this is y is equals to fx, and you may be having this is y is equals to gx, for that matter, you will see two regions within these graphs. And we have two graphs in the same set of axes. For example, within that particular region that is shaded red, that is in red, the y values which are given by the function fx are above the y values that are given by the function fx. For example, if we talk about a point like here and call it x, the y value under gx, you can see it, this is y1, and the y value under fx, you can see it, this is y2. Now that you can see y2 is greater than y1, then instead of writing this y2 is greater than y1, within these two regions, then the one marked in red, then we are simply saying fx is greater than gx. Having said that, you would also see that there's a region below where the fx sometimes is below the straight line. All this region is where the fx is below the gx. So within that region, if we could interpret it, then we are saying that the fx is below the gx. So we will see this in example 12, which is coming up. In example 12, which is coming up, and of course we can see that before we leave this one, the solution to the function when fx is equals to gx is actually highlighting the point of intersection. This is the point of intersection, and these are actually the x value on the point of intersection. We are talking about in the point of intersection, then we get the x values. Those are the solutions of this when fx is equals to gx. Example 12, I want to come up with example 12. I'll not wrap everything, but allow me to put example 12 on the board and say this. And L1 has equation y. L1 has equation y is equals to 2 plus 4x. And this is L1. L2 has equation y is equals to x squared. Part A of example 12, before we go to part A, the diagram shows a sketch of L1 and L2 on the same set of axes. The diagram here shows the sketch. Of course, when y is equals to x squared, we expect this to be L2, which is y is equals to x squared, is of that nature. And this is L1, which is 2 plus 4x. Let's go to questions. Of course, now we have a point P1 and a point P2, and these are points of intersections. Part A of the question: find the coordinates of P1 and P2. For the coordinates of P1 and P2 is actually where the two graphs intersect, the coordinates of the point of intersection. And because L2 was y is equals to x squared and L1 was 2 plus 4x, then within at these 2 points, y1, if we may talk of this one being y1 and this y2, y1 is equals to y2, because both equations give the same values of x and the same values of y at the 2 points of intersection. What does that mean? But y1 is x squared is equals to 2 plus 4x. This means it's going to be a quadratic equation, and let's solve it like a quadratic equation. X squared minus 4x, x squared minus 4x, and by the way, I would wish to note that this is 12, not 2. Please make changes. This is 12, not 2. So x squared plus 4x is equals to x squared minus 4x minus 12 is equals to 0. So the moment we have such an equation, then we can easily solve this one using the ACB method or factorization method, and we have x squared minus 6x plus 2x minus 12 is 0. So x minus 6 plus 2x minus 6 is equals to 0. So we have x is equals to 6 or x is equals to negative 2. So we know very well the value of x here is negative 2 since it is now on the left, and the value of x here is 6 since it is to the positive side along the x-axis. That is not all. We are asked to give the coordinates of the point P1 and P2. And at P1, let's start with P1, x is equals to 6. So when x is equals to positive 6, then y becomes 6 squared, and which is 36. So the coordinates of point P1 coordinate is 6, 36. And those are the coordinates of point P1. What about P2? At P2, x is equals to negative 2. So when x is equals to negative 2, y becomes minus 2 squared, which is 4. And the coordinates of P2 are given by minus 2, 4. And we have been able to answer question part A. P1, 636, P2, minus 2, 4. Let us go to part B of the question. Let us go to part B of the question. And what is part B saying? Part B is asking, hence write down the solutions to the inequality 12x plus 4 is greater than x squared. Hence write the solution to the inequality 12 plus 4x is greater than x squared. We now need to revisit the graph that we have drawn. And we are talking about the linear part. This is 12 plus 4x, not just 4, but 4x. 12 plus 4x is greater than x squared. Meaning that we are talking about the red line now. We are making it red. that is the graph of y is equals to 12 plus 4x. So, and it's supposed to be greater than x squared. It's supposed to be greater than the black graph. So within what region is the red line above the black line? That is actually the question. Within what region is red above the black at this particular point? No, because when we are having y here, then the black is up there. If you come closer, it is still below the black. At this particular point, they are together. But what about here? The red line is above the black line. And the boundary between when x is -2 all the way to when x is 6, all those values of x are going to give us the value of y when the red line is above the black line. So you can see these are the boundaries. These are the boundaries. And the solution to equation to the part B of the question is we are going to say that when x is greater than -2 and less than 6, that is when the linear graph is above the quadratic graph, as you can see. The red line within the boundaries of -2 and +2, then the red line is always above the black line. And this is simply the solution to the part B of the inequality. I wish you follow, and please note that it's not as easy as it may appear, but with understanding and with interest, there is nothing that you will not understand. All right?